Hi guys, greetings of the day. Myself Vijay Vardhan. Welcome you to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on the bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now let's start the session number 24, which is based on the check valves. And the check valves are a direction control valves which allow flow only in one direction, and hence they are called as unidirectional flow valves also. And these valves allow free flow in one direction while blocking the flow in the other directions. And these valves contains a puppet or similar items like ball, plate, etc. as the valving element. The figure shows the check valves with different types of valving element. The puppet or a ball is held by a light spring in the normally closed position. In the direction of flow, the puppet crack, that is nothing but opening at a pressure equivalent to the spring rating, and thus allowing the fluid to pass through the wall. And these walls are highly responsive and relatively insensitive to contaminations. They are suitable for high pressure applications and less suitable for large size applications. The advantages are absolute sealing ability in the closed position, and no leakage or very little leakage is going to take place. Then coming to sliding spool walls, the spool walls may be either classified as sliding or rotary type. We will discuss one by one. So first we will consider the sliding spool wall. The sliding spool wall consists of a spool inside the wall casing. Opening or closing of a port is provided in the casing by actuating the spool by an external force, which is represented by the figure over here, which shows the various parts of a spool wall sliding. Based on the position of the land with reference to the ports, the flow is directed from port P to port A or B or T or even A to T and B to T. And these are possible paths to the wall which you can see in the figure over here, which you can observe. Now, the 4 by 2 DC wall with the 4 ways each position is illustrated in the graphical symbolic representation in the previous slide, which I have shown here. And now you can see on with respect to the explanation part, the internal valving operation and the wall closing positions, which you can observe from the figure. Then coming to the 5 by 3 DC wall, which is called as center of positions. A 5 by 3 DC valve is a center of valve, that is, the valve normal position will be blocking a combination of passage and no flows takes place between P and A and P and B. The flow between P and A, BT or PB and AT are to be achieved by actuating the spool either to left or right, which you can see the figure B and C very properly. In the normal position, a combination of center of connections can be achieved, which you can see the complete illustration in this figure. Then coming to the rotary spool wall, a rotary spool wall consists of a rotating spool that is fitted into a circular wall body with closed tolerance. The hydraulic fluid is directed through the longitudinal grooves or passage provided on the rotating spools. These passages connect or block the ports in a wall body, and if necessary, a center position can also be incorporated. As the spool needs to rotational movement for its operation to change over, this type is used predominantly in manual or mechanically operated valves. And these are generally low flow valves. A rotary valves can be a line, panel or a subplate mounted. Although they can be used for reversing cylinders and motors, rotary valves are usually used as pilot valves in pilot operated direction control valves and spool sliding walls. Now the figure shows this 3 by 2 walls, which is a self-explanatory what you can observe. And coming to the next type of a rotary wall, which is based on 4 by 3 wall, and you can see the graphic symbolic representation and its working of the same. Then coming to methods of actuation of spools. To affect the direction of flow of direction control valves, the spool has to be brought to different position within the valve body. This could be achieved by moving the spool by the application of external force. Movement of spool from normal position to other positions is called actuation. The method of application of force, that is its magnitude, depends on the size of the direction control valve. The different methods of actuation employed are the manual actuation, which is represented by the figure over here. A manual actuation can be provided by using a muscle power, that is either using hands or legs. It could be a levers, push buttons, or operated by a hand, and the pedal is operated by leg. Then coming to another type is called as mechanical actuation. The spool can be operated by mechanical means using spring, roller, plunger, etc. Operations of levers, push buttons requires less force than the pedal operations. Then coming to the electrical actuation, the most common type of actuation spools in direction control valves are by using electrical power through solenoid. The electrical power may be a direct current or alternating current. The solenoid, after receiving electrical signal, actuates the valve either for closing or opening a flow path. A solenoid is made up of two basic parts, a coil and an armature, which you can see the figure. Applying electrical signals to the coil creates the magnetic field, which attracts the armature towards it. The armature in turn pushes the spool or the solenoid pin, which is connected to the valve spool stem. Then we have a pneumatic actuation based on the pneumatic flow as a working fluid, then hydraulic actuation based on the hydraulic fluid. And we can achieve this by combination of any of the above actuations or other means such as a remote controls. These are the various methods of actuation of spools. And thanks for your patience listening for the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in the session. Don't forget to like, share and subscribe. Have a great day. Signing off, Vijay Tawardhan.